page 18. So this is going to be example 11. In this example, let's read first. A burglar alarm has a system that has 6 fail-safe components. So right now, the number 6 is likely going to be the number of trials because that's a whole number and not a probability. Let's keep reading. The probability of each failing is 0.05. Okay, this is a tricky one because the probability of failure in this scenario is actually the probability of success. Notice that all the questions rely on us having the components fail, not succeed. So in this case, we're looking at a binomial model where the number of fail-safe components is our number of trials, and the probability they fail is considered our probability of success, P. Okay? Now, let's take a look at the questions. A says, exactly 3 fail. Well, hopefully you were listening on the previous problem, because if I hear exactly 3 or exactly K, where K is any number, this is a binom PDF, and we're using 6 trials. Success is them failing in this scenario, so the probability of success is 0.05, excuse me, and then I want exactly 3 of them, so I'm going to use a 3 here. Now, if you go to your calculator and you do this PDF, you will get 0.002143, okay? Let's move on to B. Probability of fewer than 2. I wanted to write this one out because we haven't seen this language yet. This means fewer than 2 is strictly fewer than, right? So that does not include 2. So this is really 0 or 1 successes. Now, we could add the PDF at 0 and the PDF at 1 if we wanted to, or we could use the CDF and we could find the CDF at 1, which would add these for us. I like it when the calculator does the work for me. So we're going to use the binom CDF, which means I need to use 6 trials. Probability of success is 0.05, and I'm going to use 1 here as the value on the end. This means for the CDF function, because it's cumulative, that it will calculate the probability at 1 and add it to every probability before that. And the only option before 1 is 0 successes. So that's going to give us the answer we want. And the answer here, if you'd put that into the calculator, which is found right underneath the binom PDF, is 0.9672. Okay, now, C. Okay, this is a very specific example. So I'm actually going to do C, and then I'm going to do a different wording for C. Now this says between 2 and 5 fail inclusive. So 2 to 5 inclusive. We're going to do this example first, and then I'm going to show you right below it the difference between inclusive and not including the 2 and the 5. So inclusive, hopefully we understand that inclusive means that the 2 and the 5 are included. So if this was interval notation, that would look like this, right? These closed brackets mean that 2 and 5 are part of our set. So in order to try to understand this better, I write out a list of all the options we want. And I go 1 beyond the endpoints here. So I like to write it like this: 2, 3, 4, 5, 6. And then we have to think about what it means to be between 2 and 5 and be inclusive. So I'm just grabbing a different color. Hopefully it works and it's not like class when all my markers don't work. 2 and 5 inclusive means we want 2 and we want 5 and we want everything between the 2. So what I think of this as is this whole value to the left here is a CDF at 5. That takes everything at 5 and adds all the things below it. And now we want to include 4, 3, and 2, but we basically want to get rid of 1 and 0, so everything below 1. So what we want to do is get rid of all of this. So we subtract the CDF at 1. If we take away the CDF at 1, we're getting rid of 1 and 0. If we make the mistake of putting a 2 here, we get rid of the 2 as well, but we want it to be kept. So let me show you what this looks like in the calculator. That would be the binom CDF, where we have 6 trials, probability of success is 0.05, and here we have 5 successes, and then we subtract, and this can all go in one line in the calculator, the binom CDF, 6 trials, probability of success 0.05, and 1. So this gives me 5, 4, 3, 2, and this takes away 1 and 0. So I'm left with everything we want. Here, if you stick this all in one line in the calculator, the answer is 0.0328. Okay, let's look at that, and then this is going to be just an added example. 2 and 5. And then the word not inclusive. Not inclusive. So I don't have to say this. I just have to say between 2 and 5. And that means do not include 2 and 5. So this is strictly between. Okay? So what that means, let's take a look at what we've got here. 1, 2, 3, 4, 5, 6. Between 2 and 5, not inclusive, means I don't want 2 and I don't want 5. So I actually only want 3 and 4. Which means just like we did up here, we start at the top of this box. I want to take the CDF at 4, these markers suck just as much as the ones in class, and subtract the CDF at 2, because I want to get rid of 2, 1, and 0 this time. Now, I have not done this in the calculator, so I'll leave that up to you. But this will be the binom CDF, 6 trials, probability of success 0.05, and 4, and then subtracting the binom CDF, 6, 0.05, and 2. And this leaves me with just 4 and 3. Hopefully you are understanding what I'm saying there. Okay, we've only got one more problem to do, part D here, okay? D says to find the mean and standard deviation of the number of failing components. So if you remember from the first video, the mean is n times p. And in this case, there are 6 components, and the probability of success is 0.05. So if I multiply these together, that gives me a mean of 0.3. Oops, mean. Okay? Now, for the standard deviation, formula was a little bit uglier. N times P times Q, all underneath of a square root. So we know N, we know P is 0.05, and if we do a little bit of math here, we know that these two are complements of one another, so this must be 0.95. And if you put this all in your calculator just like that, oops, I should use an approximation symbol there. This is about 0.5339. So that would be the mean and standard deviation for the number of failed components. And those are our 2 examples that we wanted to do in class yesterday, okay?